Okay, today we're going to look at section 1.4, which is called quadratic equations. Now, with a quadratic equation, you cannot have a equal to 0. So you have to have at least the highest degree has to be a 2. So your degree needs to equal 2. Okay, now there's many ways to solve a quadratic. What we're going to do is pick up with one way, which is the square root property. Now, in the square root property, whenever you use this, there's going to be 3 steps. You want to isolate the x squared, or it could be written as a quantity squared. Second, you want to take the square root of both sides. Third, after you have taken the square root of both sides, you are ready to solve, but do not forget your plus and minus. So for example, if you have x to the second equals 36. When you take the square root of both sides, the square and square root are going to cancel each other out. So you're going to be left with x. Don't forget the plus or minus here. So you have 2 possible answers, plus or minus 6. So you can see that 6 to the second is 36 and negative 6 to the second is 36. Okay, in example 1, if you notice, again, we need to make sure that the only thing by itself is the x to the second. So it is the only thing on the left side. So since it is completely by itself, I can square root it. Your plus and minus. So we're going to have x equals plus or minus square root 17. Now, with the 17, it does not have a perfect square that goes into it. So this would remain your answer. Okay, question number 2 is going to be similar to this type. So you notice that it is completely by itself on the left side. So we're going to square root it. Plus and minus. The square and square root are going to cancel out, which is going to be left with x minus 4. You're going to have plus or minus radical 12. Now, remember the goal is to isolate your x. So right here, I have an x minus a 4. So I'm going to have to add the 4. Then I'm going to add it to the other side. These two are going to cancel. Make sure you put that number in front of the plus or minus. Then you have to make sure nothing goes into 12. That is a perfect square. So we can break that down to 4 and 3. So the square root of 4 is going to be 2 radical 3. So again, make sure there's not a perfect square that goes into what's called the radicand. 4 does. So I took the square root of 4, put it in front of the radical, and got 4 plus or minus 2 onto 3. Now, as we finish up with the square root property, you're going to see this time these are not isolated. So in this case, you can see that there is a 5 in front of that. So in order to get rid of multiply, we're going to need to divide, because you have to have that isolated first. These two are going to cancel. You're going to be left with x minus 2 to the second equals 5. From this point, you're going to square root it. Don't forget your plus and minus. So we're going to get x minus 2 equals plus or minus radical 5. Now, again, I've got to solve for x, so I'm going to need to bring that negative 2 over. Remember that you're going to do the opposite sign. You're going to put him in front of the radical, so you get 2 plus or minus radical 5. Square root property is not too bad as long as you can remember those simple steps, okay? And the last one, number 4. Notice that we have the x squared right here. So we're going to have to first subtract our 10 because we're trying to isolate the x squared. We're going to bring down 2x squared equals 10. Again, x squared is not by itself, so I'm going to divide by the 2. Then that cancels, so I have x squared equals 5. Okay, last step, we're going to square root it. Don't forget your plus and minus. So then you have plus or minus radical 5. So that's how you solve a quadratic using the square root property. Okay, the second method we're going to look at is a more tedious method, and it is called complete the square. Okay, the completing the square is not as bad when a is equal to 1. Now, remember when I'm talking about a equal to 1, we're looking at the number that is in front of your x squared. So if there's not a number there, there's understood to be a 1. Okay, the very first step in completing the square is you want to bring c to the opposite side. Okay, so we're going to bring this number to the opposite side, and I'm going to put these blanks. So you can think about completing the square as you've got to complete blanks. Okay, so we'll bring that over. Now that changed signs because I added it to get it to the other side. Okay, so step 1, you want to make sure your constant number, c is constant, that is your number without the variable, is on the opposite side. Okay, step 2, you're going to take half of b and you're going to square it. Okay, half it, square it, put it in the blank. So we're going to half it, square it, put it in the blank. So right here, I'm going to half it, square it. Okay, so when I half this, because b is your negative 4, I'm going to get negative 2. When I square it, I get a 4. So that's going to go on both sides. So we're going to half it, square it, put it in the blanks. So this is your formula that you're using to put in the blanks right there. Okay. After you do that, step 3, you're going to factor. So you're going to have to factor the left side, and you're going to combine the right side. Okay, so right here, you're going to factor this trinomial. So it's going to break down to, if you remember, it's got to multiply to be 4, and add to be -4. So your signs are going to have to be minus, minus, 2, and 2. Now, it's always going to be a twin factor, and it's going to go back to this right here when you break that back. So it's going to go back to your -2. So this is going to be an x minus 2 to the second because it's a repeated factor. So when you factor this, it's going to be the same thing twice, okay? Here, you're just going to combine the numbers. So you're just going to put these numbers together. So that's going to be a 16. From here, you're going to notice that you're just going to go back and you're going to do the square root property steps. So now we're back to your square root property. So that's what we just looked at. Remember, to get rid of that, you're going to square root it. Don't forget your plus and minus. These two are going to cancel. 16 this time comes out to just be 4. So this time we have no radical in the answer. So now we're going to add the 2 over like we did earlier, and we're going to have 2 plus or minus 4. So these two answers would come out to be 2 plus 4, and the other one would be 2 minus 4. So it would be 6 and -2. Those would be your two answers for that. So if your square root goes away, you do need to combine those numbers because the square root of 16 dropped to give you that 4, okay? Now, this would be one of the most difficult ones because you're going to have to encounter a lot of fractions. So if you recall me saying earlier that A needed to be 1 for us to follow those steps, but right now, A is equal to 9. So that's going to cause us an issue here. If that happens when you are completing the square, step 1, you have to divide every term by that number. So you're going to have to divide every term by A. So whatever your A is, you're going to need to divide every term by that. So we're going to divide every term here by 9. So you can see that we're getting some fractions here. So this is going to be x to the second. This is going to reduce to 4/3. Then we have a plus 1 equals 0. Okay, once you get to that part, you're going to repeat your steps. So if you remember, step 2, we want to make sure that we put the blanks, and we want to bring our C to the other side. So I'm going to go ahead, bring this down. I'm going to put a plus blank. When I move 1 to the other side, it's going to be a -1. Okay, step 3. Remember, we're going to half it, square it, put it in the blank. Half it, square it, put it in the blank. So we're going to do -4/3, and we're going to divide it by 2. Now, remember, when you divide fractions, it's like multiplying by the reciprocal. So I'm going to multiply by 1/2. That's going to give me -4/6, which reduces to -2/3. So I've halved it. Now I'm going to need to square it. When you square something, it's like multiplying it to itself. So that's going to give me a 4/9. That's what's going to go in the blank, 4/9. So I'm going to put that here and there. Okay. Then I'm going to repeat that process again from earlier. Remember, this is going to factor to the same thing twice. I'm going to combine the numbers on the right. So I'm going to go back. I'm going to put a quantity squared. If you recall while ago when I told you about the factoring, it's going to go back to this part right here when you're factoring it. So you're going to take this sign, and it's kind of like taking your square root, x minus 2/3. And you can see that a negative 2/3 plus negative 2/3 would give you the negative 4/3 in the middle. Now, when I combine those numbers on the right, I'm going to get a common denominator. So that's going to be like negative 9/9 plus 4/9. That's going to go together and give you a negative 5/9. Now, we're back again to the square root property. So once you get it to that part, you're ready to go through and start taking your square roots and your plus and minus. So this is going to go to x minus 2/3 equals plus or minus. Now, remember, when you have a negative under the square root, you're going to take out an I. So that top is going to simplify to I onto 5. The bottom, which is a square root of 9, will go to a 3. Then you're going to bring that over by adding the 2/3. So you're going to get x equals 2/3 plus or minus I onto 5 all over 3. And that would be your solution to that question. So, if you struggled with that, which if you've never done completing the square, or even if you have, when A is not 1, it does become very tedious with the fractions. So again, you can use your calculator if you need to. I do like you to have an understanding of how to do the numbers in your head. But if you go back and you were to type this into the calculator, if you put that in parentheses, negative 4/3, and you're dividing it by 2, you're going to see that I get that negative 2/3 right there. From here, you can hit the x to the second button. It'll take that answer and square it. And then when you math enter, you're going to see that you get the 4/9. Okay, so again, you can type in that as well, the negative 1 plus 4/9, and then just math enter. So it's good to try this without a calculator, and then if you can't get the right answer, go back and see where you're messing up with your math. Okay, step 3 deals with the zero product property, and what that means is you're going to utilize factoring. This is probably one of my favorites, but if you struggle with factoring, it is something that you really need to see me on, and you really need to try to understand, because you're going to be utilizing that through the course and all of your other math classes. So the first thing, you want to take it and you want to set it equal to 0. Factor means that you're going to break it apart, and you're going to use parentheses to break this apart. And then you're going to solve for each letter, because you're going to have what's called linear factors. So it's going to be easier to solve for the variables after you have broken it apart. So what we're going to think about first is when you do factor, I'm going to draw like a flow chart. When you do factor, the thing that you always do first is you want to see if something goes into all of the parts of the problem. So you're going to look for what's called a GCF. Okay, so that's what you're going to do first, is always divide and reduce that. So if we were to have something like, we're just going to say an easy question like 2x plus 4. And you're trying to see what goes into all of those. So you can notice that your number here, 2, goes into itself and 4. So what you do is you reverse distribute. So you're going to divide both of those by 2, and you would get an x plus 2. So that's how you would factor with GCF. So it's almost kind of like reducing the problem, but you do have to put it in front of your parentheses. Okay. After your GCF, you're going to have to determine how many terms you have. So in this section, we're going to be looking at things that might have 2 terms, and those things are called binomials, if you remember. Okay, so when you have 2 terms, there's 2 things that you want to look for. Sometimes you might have what's called a difference of squares. Difference of squares. Okay, so a difference of squares would be something like this. You might have 4x to the second minus 16. And in a difference of squares, you take the square root of both of these. So that would be a 2x and a 2x. Kind of like our conjugates, it's going to cancel the outside and the inside. So you're going to have 2 different signs, minus 4 and plus 4. So when you hear me say difference of squares, that would be that rule. Okay. Second, you might encounter what's called a sum of cubes. Now, cubes means 3. So if you were to have x to the third plus 8, when you factor a sum of cubes, you always get a bi and then a tri. So this is going to factor to the cube root of x to the third is x. The cube root of 8 is 2. And cube means what 3 things multiply to give you 8. Now for the rule, you always square the first, multiply the 2 together. This sign is always different. And then you square the last. Okay, and you can also have what is called a difference of cubes. Okay, so if you're looking at what's called a trinomial and you have 3 terms when you're factoring, there's a rule for if A is equal to 1 and then if A is not equal to 1. So if A is equal to 1, remember it's multiply and add up. So it's got to multiply to be -8. And it's got to add to be 2. So when we're thinking about -8, you can have these numbers. And 4, -4 and 2. Okay, so it's got to add to be 2. So if I take those 2 numbers and add them up, I get -7. I need to fix this to a negative, don't I? So -1 plus 8 would be 7. -2 plus 4 would be 2. And -4 plus 2 would be -2. So once you found the 2 that work, so notice that works here, and it also works about the adding, that's going to be your 2 factors. So when we factor this, it's going to tell us exactly what sign to use. So that's going to be x minus 2 and x plus 4. And again, I would definitely FOIL it to check yourself. So if you're foiling, remember that's going to be x to the second, 4x for your outside. Your inside was the little small. That's -2x minus 8. So these 2 right here go together to give you x to the second plus 2x minus 8. So that tells you that you factored it correctly. So remember, factoring is where we're breaking apart. Okay? The next example is going to deal with A is not equal to 1. So you would have a problem where you would have a number here where A is not 1. So this is where you're going to have to do some guess and checking. So it's very important to do that check with the FOIL when you're guess and checking. Okay, so what you want to do is you want to look at your factors of your first term, which is going to be 1x and 2x. Or you could list it as 2x and x because multiplication is commutative. You're then going to look at your factors of your last term. So you would have 1 and 15, 3 and 5, or you could flip-flop those numbers, okay? Just like I did on that first one. So these are the two that you're going to focus on at the beginning. You're not going to worry about this right now, and you're going to place your factors. Okay, so I'm just going to start with 2x and x, and I'm going to put that in the first slot. Now, remember, it's got to multiply to be a negative 15. So that tells me the signs are going to have to be different on those numbers. So it could be a negative 1, 15, a 1, negative 15. So we're just going to have to try to see when we check which ones are going to work. Now, I always start with my lower numbers and then I'll work up. That way I know kind of where I'm at. So I'm going to try the 5 and the 3. Okay, and I'm just going to go ahead and put down different signs. And this is how I would think about it in my head. So then I would multiply the outside, which is going to give me a 6x. I would multiply the inside, which gives me a negative 5x. Now, these two numbers right here have to go together to give you the negative 1. That's where the O and the I come together, right there on the outside and the inside. So notice that I have a positive 1. So if everything is right but the signs, all you have to do is change these. So I'm going to change that to a plus now, and this one to a minus. So you can see once I flip-flop those, I get that negative 1 right here. And that tells me that these two right here are going to be my factors. Okay, so just don't put your answer until you've tried everything and ruled out all of those. And if you rule out everything, it is possible it's prime, but there's other methods we can use if things can't factor, is what I was trying to get across a while ago. So if things can't factor, we can always resort to completing the square, or the last thing method that we're going to talk about, quadratic formula. Okay, so since we talked about factoring, we're going to utilize this in the zero product property that we were discussing. So the first thing with the zero product property, like I mentioned at the beginning, is to set it equal to 0. So whenever you're factoring, you do want the problem set equal to 0 before you break it apart. Okay, then we're going to try to factor. So we're going to break this apart now to the parentheses. So this is a trinomial with A1. So I'm going to go ahead and make the two parentheses. And I'm going to go ahead and put down for my first term. So my first term for x to the second is going to be x and x. Now it's got to multiply to be 6. So it's got to multiply to be a positive 6, but it has to add to be a negative 5. So that tells me my signs both have to be negative. So I believe that's going to be a 3 and a 2. So negative 3 times negative 2 is 6. Negative 3 plus negative 2 is negative 5. Then you're going to solve for each variable. So in order to solve for each variable, you utilize that property by taking the first factor and setting it equal to 0. So that's your first linear factor. You take the second one and you set it equal to 0. And then we're going to add your 3. So x comes out to be 3. And then I would add the 2. And x comes out to be 2. Now you can also check those by plugging those back into the calculator. So if you're doing 3 to the second minus 5 times 3 plus 6, it should give you 0. And the other answer we got was 2. So I'm just going to replace that with 2 this time. And we also get 0. Okay, this one would be considered a difference of 2 squares because it is 2 terms. So when you have the 2 terms, think about your conjugates. So what's going to multiply to be negative 64 and add to be nothing would be negative 8 and positive 8. So then you're ready to solve by setting those equal to 0. So x would be 8 and x would be negative 8. And you might also see that answer written as x equals plus or minus 8. Okay, so we'll try one now where a does not equal 0. So let's try 4x squared minus 4x plus 1. Okay, so we're going to break this apart. Notice my a is 4 this time. So we could do 1 and 4 or 2 and 2. Always start small. So I'm going to do a 2x and a 2x. Like I discussed earlier, if it's minus plus, it needs to be minus minus. So the only thing for 1 is 1 and 1. So let's see if this works. Negative 2x and negative 2x does add to give you negative 4x. Okay, so this is called a repeated factor, which means you're going to get the same answer twice. So you can just list that one time. So 1/2 would be the solution to that problem. Okay, the next thing we're going to discuss about is the fourth way to solve a quadratic. And the good thing about the quadratic formula is it always works. Okay, so the first thing we're going to look at with the quadratic formula, though, is called the discriminant. So the formula for the discriminant is b squared minus 4ac. Now, when you do this formula, if you get a positive perfect square, which I'll just put like an example down here, let's say that we get 36 for the discriminant. That means that you're going to have 2 solutions and they're going to be rational. And they will be real. Okay, if you get a positive, not a perfect square, you're still going to get 2 solutions, but instead of rational, it would be irrational. They're still going to be real numbers. So this would be maybe you got the number 5. It is a positive number, but it's not a perfect square. Okay, if you get 0, whenever you get 0, you're only going to have 1 solution. It will be considered rational and real. Now, if you get a negative number, okay, 0 would just be like, 0. If you get a negative number, say that was negative 5 a while ago, you're still going to get 2 answers. The only time you get 1 is if you get 0, okay? But this time, they're going to be considered non-real, complex, because you're going to have i's in your answer, okay? So this is when you would have like i's in your solution. Now, the formula for the quadratic formula, you want to, first of all, set it equal to 0. You want to identify A, B, and C. And then your formula, if you remember, is negative b, plus or minus, square root, b squared minus 4ac, b squared minus 4ac over 2a over 2a. So remember, that is the formula that you're going to be using to solve the questions. And again, it works for every type. Okay, so let's take a look at this question. So we're going to be using the quadratic formula. So the first thing I want to do is set it equal to 0. Then I'm going to identify my a, which is 1. My b is -6, and my c is 7. Now, I like to go ahead and get the discriminant first and then plug this into the formula. I just feel like it makes it a little bit easier and less hectic. So I'm going to go ahead and get b squared minus 4ac. Okay. So if I plug that in and you use your calculator, you need to make sure you put parentheses for where you're plugging that in at. So you would type it in like this, and that would give you the number 8. Now, if you're doing it in your head, that would be 36, because you would use the order of operations. So I'm going to multiply, that'd be -4. That would be 36 minus 28, which would give you 8. Okay, now this discriminant is going to tell me that I'm going to get 2 solutions. They're going to be real, and they're going to be irrational. Irrational because it's not a perfect square. You're going to have a radical left in the answer. Okay, so when I look at this, remember it is -b, so we're going to change the sign of this, plus or minus. This goes in for the b squared minus 4ac, and then it's all over 2a, which is 2. Now you do need to make sure you simplify your radicals. So that's going to go to 6 plus or minus. So we got a 4 and a 2, which is 2 on the 2 over 2. Now, if this number goes into both of those, go ahead and reduce it. Do not take the 2 and put it into that 2 that's under the radical. You can't do that. So then the answer would be 3 plus or minus radical 2. Okay. So quadratic formula shouldn't be too bad. We'll do one more with quadratic formula, and then we'll finish up with some of the literal equations. So let's try this one because I want to talk about the negative part. Okay, when you see that one, you can work with it that way, but I would probably take a look at trying to get this one positive, just because it sometimes helps with your plugging in. So know that you can move things this way. That way we don't have to deal with all those negatives, okay? So let's go ahead and get your discriminant. So it'll be b squared minus 4ac. And that's going to be -39, which tells me I'm going to get 2 non-real complex. Okay, so when I do this one, I'm going to have -b plus or minus radical -39 over 12. So that's going to simplify to -3 plus or minus I on the 39 over 12. Now remember with these, they want you to put these into standard form. So you're going to have to put these in the a plus bi form, which means we're going to break this apart and put the 12 under both of these. So that's going to reduce to -1/4 plus or minus I on the 39 all over 12. So remember to put those with the a plus bi form. That's your standard form for a complex number. And the last part, you might encounter some what's called literal equations, which means it's going to give you an equation and you have to solve for a specific variable. So if we had area equals pi r squared, and we're going to say that you have to solve for r. Okay, so we're going to first get rid of multiplication by dividing. So I'm just going to turn it around like this. R squared equals a over pi. Okay, remember to get rid of a square, you take the square root. Don't forget your plus and minus. So we're going to have r equals plus or minus. And I'm going to break this up because the square root is on both parts. Now, remember, you cannot have a radical on the bottom. So to get rid of that radical on the bottom, you're going to have to times by the square root of pi. So you're going to get plus or minus a pi over pi. And as we finish up, pay attention to, like, if it asks you to solve for a specific variable, one could be capitalized and one lowercase. To get rid of a fraction, the easiest way here would be to cross multiply. So I'm going to put a 1 under that to make it a fraction and put e squared k equals, and that would be 2r capital E. So then we're getting rid of multiplying, so we're dividing. So we have e squared equals 2re over k. We're taking the square root. Don't forget plus and minus. So we have e equals plus or minus square root 2re over square root k. You probably want to do it this way first, where you can then get rid of your radical on the bottom. So then we're going to multiply by the radical k. So we get plus or minus square root. Now with your variables for this one, I'm just going to put the capital one first. And then I'm just going to put the RK over K. You can have them in a different order. Just pay attention to what the directions are saying when you're typing those in. So remember, don't leave the radical on the bottom. So to get rid of a radical on the bottom, just multiply that by itself, okay? Hope this helped. Have a good day.